We've been here before. Astronomers detect a possible biosignature on a faraway world, only for it to turn out to be something boring like rocks or methane. But this time could be different. Scientists just reported the discovery of 2 compounds on an exoplanet that here on Earth are produced only by living things. So could we finally be on the verge of discovering alien life? Let's dive into what's happening and what comes next. This intriguing story began with a very average star system. It's a relatively small star, about 200 light-years away, and orbiting that star is at least one planet roughly the size of Earth. The planet, known as K218b, was first discovered in 2006 using the Keck Observatory in Hawaii. Follow-ups with the Hubble Space Telescope revealed that the planet is in the habitable zone of its star, meaning it could theoretically have a liquid water ocean. That makes the planet a prime target in the hunt for life beyond Earth. The new study was conducted by researchers at the University of Cambridge and the University of Berlin. They used data from the James Webb Space Telescope to analyze starlight as it passed through the planet's atmosphere during a transit. When starlight filters through an atmosphere, it interacts with the gases present, leaving a unique signature that can be detected by JWST near-infrared instruments. This method has already proven successful with the discovery of water vapor in the atmosphere of WST-39b, an extremely hot gas giant around 700 light-years away. However, analyzing the data from K218b proved more challenging. The planet's atmosphere was previously thought to lack clouds, making it easier to spot potential but the latest findings suggest otherwise. Lead author Dr. Ingo Waldman explained in a statement, "When we looked at the data, we were surprised to see that the spectrum looked much more complex than expected. There are so many features that indicate the presence of clouds in the atmosphere. However, after further investigation, they realized that these unexpected features could actually help them identify what kinds of clouds were present, and that led to an incredible discovery. Through careful analysis, the team found 2 specific features in the light spectrum that could only be attributed to dimethyl sulfide and dimethyl-D, better known as DMs on Earth. DMs is produced exclusively by living things like phytoplankton in our oceans. It's released into the atmosphere when these organisms die and quickly makes its way into the air, eventually forming clouds. Although scientists have yet to confirm the exact mechanism behind DM's production in living cells, it is generally accepted that it plays a role in protecting cells from damage caused by excess sunlight. The fact that this compound is produced exclusively by life, as we know it, makes it a promising biosignature in the search for extraterrestrial life. While the detection of DMs in the atmosphere of K218b is tantalizing, there are still some questions that need to be answered. One of the main challenges is that DMs can also be produced abiotically, meaning it can form without the involvement of living things. For example, it has been found in meteorites and interstellar clouds. However, the researchers believe that the DMs detected on K218b is likely of biological origin, because the amount present in the atmosphere is far greater than what would be expected from meteorite impacts alone. Additionally, the detection of dimethyl, which is only produced by living things on Earth, strengthens the case for life on K218b. Co-author Dr. Ryan McDonald stated, "It's not a smoking gun, but it's certainly a very interesting clue in the search for life elsewhere in the universe. If confirmed, it would represent the most exciting discovery in my lifetime, and probably the most important scientific discovery since the discovery of fire." Of course, other scientists are more cautious. Experts like David Kipping from Columbia University, who was not involved in the research, highlighted the need for further investigation before drawing any firm conclusions. Kipping suggested waiting for observations from the Nancy Grace Roman Space Telescope, which will conduct exoplanet transit studies with a wider field of view. These observations should help determine whether the DM signal is real, and if so, shed light on its origin. K218b is currently too far away for JWST to observe in such detail. Again, but once the Roman telescope is operational, follow-up observations will be possible. In the meantime, astronomers are excited to continue exploring other tantalizing clues in the search for alien life. For example, the discovery of phosphine on Venus has reignited debate about the possibility of life on our neighboring rocky planet. Phosphine is typically associated with oxygen-rich environments like Earth's oceans and wetlands. Its detection in Venus's atmosphere raised eyebrows, as it could potentially indicate the presence of microorganisms thriving in Venus's extreme conditions. However, scientists have since proposed alternative non-biological explanations for the phosphine signal, such as chemical reactions involving volcanic activity. Despite this setback, recent advancements in analytical methods have allowed scientists to re-examine old data and uncover new insights. A new study published in Nature Astronomy has revealed the presence of long-chain organic molecules on Mars using data from NASA's Curiosity rover. These molecules, including linear and branched alkanes and alkylated benzenes, are building blocks of life and were found in rock samples collected from the Gale crater region of Mars. Although the discovery does not provide direct evidence of past or present life on Mars, it does offer clues about the planet's past habitability. Curiosities. Sampling location. The Gale crater was once a lake, and the presence of these molecules suggests that liquid water existed there in the past. Furthermore, the molecules provide insights into the types of rocks that were exposed to the surface of Mars in the past. Branched alkanes, which are typically produced by living things on Earth, were found to be more prevalent, indicating that they may have originated from organic matter. The researchers also discovered alkylated benzenes, which are thought to form under both biological and non-biological conditions. While the exact origins of these molecules remain uncertain, their discovery adds to the growing body of evidence that Mars was once habitable. Researchers are now exploring the possibility of drilling deeper into the Martian surface to search for signs of ancient life. One mission that could provide answers is NASA's Europa Clipper, scheduled to launch in October 2024. The spacecraft will conduct multiple flybys of Jupiter's moon Europa, investigating its subsurface ocean, which is believed to contain more water than all of Earth's oceans combined. The Clipper will measure Europa's ocean depth, map its surface and composition, and search for evidence of past or present life. Equipped with a suite of scientific instruments, the spacecraft will analyze the moon's surface materials, including rocks and ice, to understand its geological history and habitability. Additionally, the Clipper will investigate Europa's atmosphere and magnetosphere to gain insight into its interaction with Jupiter's intense radiation environment. Another exciting prospect is the Habitable Worlds Observatory, a proposed space telescope designed to detect biosignatures in the atmospheres of The observatory is currently in the concept stage, but if approved, it would be equipped with advanced instruments capable of analyzing the atmospheres of smaller, rocky planets like the Earth. The telescope's powerful spectrographs would allow it to identify the chemical composition of exoplanet atmospheres with unprecedented precision. With the ability to observe planets at various stages of their atmospheric the Habitable Worlds Observatory would revolutionize our understanding of planetary habitability and the search for life beyond. Earth's technology continues to advance. We can expect even more groundbreaking discoveries in the field of astrobiology. The detection of DMs on K218b is a remarkable achievement, marking a significant step forward in our quest to find life beyond Earth. While further investigation is warranted, the discovery serves as a reminder of the incredible potential of human ingenuity and scientific exploration. One thing is for sure: the search for alien life is more exciting than ever before. From studying the atmospheres of distant exoplanets to exploring the depths of our own solar system, scientists are leaving no stone unturned in their quest to find life beyond Earth. And who knows, maybe one day soon we will discover that we are not alone in the universe. If you enjoyed this video, check out the playlist, where we explore the latest discoveries in the search for extraterrestrial life. And don't forget to subscribe to stay up to date with all of our videos. Thank you for watching, and I'll see you next time.